Okay, so let's draw a free body diagram of today's lab setting and think about how we can use the angle of the slope to calculate the coefficient of friction. So let's draw a slope right here. A slope, and then we have an object on it. And assume we're taking a snapshot of the instant when the block just about to slide down. Right? And we record the angle, called it theta. And we're going to use the angle to calculate the coefficient of friction. So the first thing first of drawing a free body diagram is to list all the forces in this situation. So think about how many forces can you think about on this graph. The first thing would be the weight of the object, right? Weight. The weight. And also there's the block is not sliding down because there is friction. So there is friction. And also the object is not sliding on this direction. So there is something supporting it, right? So that's called normal force. Normal force, which is perpendicular to the surface. All right, so right now I'm going to show you a simple trick or a pretty common trick to solve this problem is to make the force, to divide the force onto the direction you want it to be to simplify the question. So for example, we're talking about friction right now, right? We're talking about friction. We are talking about friction. Again, friction. Yeah, works. Okay, we're talking about friction. So we want all the forces to be on the direction which is either parallel to friction or perpendicular to the friction. So think about the normal force is on the direction that we want it to be. The friction, of course. How about the weight? The weight is not. So we want to divide the weight onto two directions that we want it to be. So the first thing will be perpendicular to the surface, right? And also parallel to friction. So we divide this weight onto two forces. And like by the vector or linear algebra, we now actually adding these two forces together would become this force. So actually we didn't change anything. We just divide one force onto two forces. And use some trigonometry. We know here is theta, so this angle will be theta. And the angle here, so this force will be weight times cosine theta. All right. And this force will be weight times sine theta. That's trigonometry. All right, so now we're done with like dividing all the forces, but then what's next step? We know on this direction, on the direction that is parallel to the friction, there are two forces. One is friction, the other is the part of the weight, which is weight times sine theta. And when it just starts to slide down, actually, this force should be the same as this force, right? So we can list it up. Friction equals to weight times sine theta. And how about on this direction? The block is not sliding on the vertical direction to the surface, right? So actually, normal force is the same as weight times cosine theta, right? So we have normal force equals to weight times cosine theta. So what? We got these two. We got the friction, we got a normal force. And if you remember in the last video, we have a super important equation, which is friction equals to mu times normal force. Right? Friction equals to coefficient of friction times normal force. And right now, we have friction, right? Here. We have normal force. Put them together, we should be able to get the coefficient of friction. So let's do the magic. Friction equals to weight times sine theta. So we list it here. Weight times sine theta equals to mu times normal force. The normal force is weight times cosine theta. So weight times cosine theta. So we know with some high school math, there's weight and weight on both sides of the equal sign, right? So you can cancel it, weight and weight. And we're going to move cosine theta this way. So we have sine theta divided by cosine theta equals to mu. And if you remember, sine divided by cosine equals to tangent. So that's it. That's the equation we want. Mu, the coefficient of friction, equals to tangent theta. So as long as you have the theta, you have the angle, take a tangent of it, you will get a coefficient of friction in this situation. Magic. All right, so that's how we get the equation, and you're going to use this equation to finish your assignment. That's about it. And I'll take a picture of this, like writing. So yeah, I'm not sure about the video quality, so hopefully it's good. All right, see you later.